Quadratic equations. Because things aren't always going to be straightforward, but that's okay.
Hello.
The quadratic equation. The next step after completing the square is to rearrange to make x the subject to torture. Just kidding, to make x the subject to find the root. Sometimes you've got to see a number for what it really is to get to the root of your problem. And your problem isn't always as straightforward as ABC, or easy as 1, 2, 3, or simple as do, re, mi, ABC, 1, 2, 3, baby, you and me, girl. Pardon me, I could not help it. Anyhow, sometimes finding a root is like finding the roots of one tree in a jungle. I hope I was fun and games because I ain't feeling too welcome just yet. Jungle, welcome to the jungle. Sorry man, I can't help it. I like to sing. What's the problem here? Sure, to solve a quadratic formula, you can always use a graph. But what if, just hear me out, you don't have one? No graph, no problem. As you know, the quadratic equation is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, where the equation needing solving holds the form ax squared plus bx plus c is equal to 0. Proving the quadratic equation is pretty easy too, just like proving that you're guilty. The entire equation is literally just making x the subject. That's it. Mathematically, of course, since romantically you never know what the future holds. The first step is to complete the square, but there's a little catch this time. Let's use some placeholder values to find out what the rightful coefficients are. Don't be confused by them, just bear with me for the time being. So let's start off with this equation with terms of d, e, and f. So remember that the equation must be equal to 0, since that's what a root actually is. The x value is when the y value is 0. It's called a root since it's where the graph touches the x-axis, or the ground if you will. Expanding out gives d... Wait, no, that's not what I meant by expanding d. You guys are dirty. Get your minds out of the gutter and get some Jesus! We now need to find the values of d, e, and f using simultaneous equations. And once we do that, it's all cool. Now we can quickly and efficiently complete the square with the quadratic equation, just substituting the above for d, e, and f. Man, you guys really have me talking about these a lot here, don't you? After some rearrangements, we can make x the subject and the hard part is over. Now, let's square root both sides, and just remember that the root can be positive or negative. After that, we can divide by a to the power of 0.5, or the square root of a if you want to call it that, and bada bing, bada boom. We have a quadratic equation, ladies and gentlemen. Let's give it a standing ovation! The number of roots in a quadratic. The equation will have two roots if b squared minus 4ac is positive, since you'll have one with the positive square root of b squared minus 4ac and one with the negative root of b squared minus 4ac. This means that your graph will touch the x-axis twice, and that there are two x values which make the original equation, y is equal to ax squared plus bx plus c equal to 0. For example, we have the graph here of y is equal to 2x squared plus 5x plus 1, and as you can see, it touches the x-axis twice. Hey, it's so nice I had to name it twice. I can't even say the name of the source because that'll give me a copyright strike or something. Anyway. Your equation will have one root if the value of b squared minus 4ac is 0, since the square root of 0 is just 0. No-ish, Sherlock. So the root of your equation will just be in the end minus b over 2a. This means that there's only one root that will make the original equation y is equal to ax squared plus bx plus c equal to 0, and the equation just skims the x-axis once. Damn, I guess graphs can have one-night stands too, you know what I mean? If b squared minus 4ac is negative, the equation doesn't touch the x-axis at all, since there's no such thing as a square root for a negative number, which means there's no such thing as x is equal to minus b plus or minus the square root of a negative over 2a. So I guess safe to say that that graph doesn't get none. It don't get no action. Poor graph, brother. There are plenty of fish in the sea. Don't worry, brother. The quadratic equation scenario question. We've just discovered a new species of butterfly in the Siberian tundra. Ooh, butterflies! Which play a vital role in pollinating flowers in the region. So I guess butterflies can make good wingmen and wing women too. Pun intended. No, shut up, yes it was intended. We only have limited data on the age versus number of eggs laid, so we don't know the sexual maturity age, which is very important ecological data. Wow, how am I speaking about sex ed for butterflies? Who wrote this? Oh wait, I did. Never mind. Anyway, here's the data we've collected with an equation data fitted by Excel, with the graph currently having an equation of y is equal to minus 6x squared plus 89x minus 230. Like I already said, the sexual maturity, entry and exit age of an animal is vital for ecology. So let's complete the square to find those. We eventually get x is equal to 3.33 and 11.5 days. So I guess we can round them up to 4 days and 12 days. What? Were you expecting a joke? It's butterflies getting jiggy with it. What am I supposed to say? Don't look at me. What, do you think I'm a butterfly? The quadratic equation structure. Awesome, but what about when powers aren't squared? What if we had ax to the power of half plus bx to the power of quarter plus c is equal to 0? Let's substitute x to the power of half into z squared, which then means x to the power of a quarter is just equal to z. We then get z squared plus bz plus c is equal to 0. Hey, this is a quadratic equation just with z instead of x. Plus bz kind of sounds like the Bee Gees. Stay alive. Pardon me. This also then just means that z is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. But then substituting means x to the power of quarter is also equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Man, you don't have me rapping over here. This then just means that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a to the power of 4. So long story short, if we have something in the form x to the power of 2n plus bx to the power of n plus c is equal to 0, we can then just substitute x to the power of n is equal to z to the power of 1, which eventually gives us x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a to the power of 1 over n. Just bear in mind that the important thing is the structure, as this will only work if the power on the b is half the power on the a, and the power on the c is 0. So if we had something in the form ax to the power of 2d plus bx to the power of d plus c. So something like x to the power of 0.7 plus bx to the power of 0.2 plus c, that's not any kind of quadratic, so yeah, we can't do anything with that. We just have to chuck it in the bin where it belongs. I don't know if it's something in the air in the Arctic Circle, but I saw the craziest thing. I was lost in the Siberian forest after a bear attacked me and destroyed my compass and gear. I was totally directionless, starving, and genuinely thought I was soon to meet my maker. Then suddenly, a reindeer with a raven on its antler appeared to me. I read once that in the Native American zodiac, a raven is considered a messenger from the cosmos. And lo and behold, the damn bird spoke to me in plain English. It said to me that my mission wasn't over yet, and that I was chosen, and everything I've done will amount to something, provided I have the willpower to see it through. It also somehow told me to construct my own compass and some useful survival tips that did actually end up saving my life. It even told me where the nearest human settlement was, which turned out to be correct somehow. Was this divine intervention, or was I tapping into the deepest parts of my subconscious mind and memory? Either is fine with me because I didn't become a snow mummy.